Hi everyone, I'm going to talk about crystallization and drying. It is one of the downstream processing used for product polishing step involved in the purification of product. First, product finishing. Product finishing describes the final processing step which ends with packaging of the product in a form that is stable, easily transportable and convenient. Crystallization, desiccation, lyophilization and drying are typical unit operations used in product finishing step. Now crystallization. It is a process of formation of solid crystals precipitating from a solution. It may be initiated by either cooling or by evaporation. Some of the factors influencing solubility in crystallization are concentration, temperature, polarity, ionic strength, etc. Importance of crystallization. Remove close related impurities from the desired product. Crystallization plays an important role in this step. And also, crystalline powder is easily handled, stable, possesses good flow properties and an attractive appearance. It yields uniform sized and shaped crystal. These are the major process where the crystallization plays an important role. And theory of crystallization. There are three major stages in the process of crystallization. It includes supersaturation of the solution, nucleation, crystal growth, etc. Now, supersaturation of the solution. It can be done by three ways. By heating the solution or cooling the solution or increasing the concentration of salt in the solution, which means it is a salting out method. Now the degree of supersaturation of a solution can be described by using one formula. This is S equal to Ct by C naught, where S is the degree of supersaturation, Ct is the concentration of solute in solvent and C naught is the concentration of solute in saturated solution. There is a two condition where this S may plays a major role. Yes, when S equal to 1, it means condition will in solubility range, and yes greater than 1, it is a supersaturated condition that the solution attained the supersaturated condition. Now nucleation. This takes place in several steps. During their random motion, the atoms and molecules will come close together and form aggregates. This is called clusters. These clusters become stable and form a critical cluster size. Now crystal formation will occur. Next, crystal growth. Once the crystals are formed, nuclear formation stops and crystal growth begins. Can be described by one equation, dm by dt is equal to k into a into c minus c star, where m is the crystal mass, a is the surface area of crystal and c and c star are concentration of solute in the supersaturated solution and the saturated solution. Now equipments. Crystallizer is the equipment used for the crystallization process. Mostly in industry, to achieve liquid solid separation, crystallizers are used. They are capable of generating high purity products with a relatively low energy input. It may be batch or continuous process. There are two main types of crystallizers. One is evaporative crystallizer and another one is cooling crystallizer. Now, evaporative crystallizer. Evaporative crystallization increases the concentration of solution by evaporating the solvent. Now, the concentration increases, the solution becomes supersaturated and nucleation begins. Once the nucleation stage attains, the crystal will form and it attains a crystalline nature. And there are two main styles of evaporative crystallizers are used. First one is draft tube crystallizers, a continuous vacuum evaporative crystallizer. It is one of the continuous system used for a crystallization purpose. This model utilizes a low speed propeller to direct the mixer upward through a draft tube toward the boiling surface to be evaporated. Now the supersaturated product enters into a chamber containing a mixture of solids and solution. Now it attains a saturation point and it forms a nucleation. Once the nucleation stage attains, crystal size and uniformity of size depend on external separation, so crystal will occur. This is the draft tube crystallizer used in industry. Now, submerged circulated crystallizer. It is one of the evaporative style crystallizer. It is the batch type crystallizer used in industry. It contains two modes. One is external circulation mode and internal circulation mode. In external circulation mode, the solution is pushed through heat chamber at a high velocity. This model allows minimal crystal formation on the tubes. In case of internal circulation, the solution is pushed by a propeller through a draft tube to circulate internally while a hot feed supplies evaporation energy. But both version requires agitation or circulation to ensure small pure crystal formation. This type of crystallizer is useful for larger capacity with the same external control of size and size uniformity. This is the submerged circulating crystallizers used in the industrial field. Now cooling crystallizer. In this process, crystallizing the solution based on solubility temperature dependence. Now, this method causes some of the solution to evaporate and then cool to a temperature in equilibrium with a reduced pressure. This process is mainly due to the change in temperature of the solution. While decreases the temperature, the solution attains the supersaturated condition and the nuclei will form. Now, it encourages the crystal growth to form crystals. So, it can be performed by using vacuum cooling crystallizer, continuous cooling crystallizers or scrapped surface crystallizer. Vacuum cooling crystallizer. It is useful for maintaining tighter control of crystal size. This vessel utilizes either a batch or a continuous mode of crystallization process. Now continuous cooling crystallizer. This model removes a slurry to a centrifuge, returns centrifuge dilute solution to a evaporator, then supplies this concentrated warm solution to the cooling crystallizers. By this way, the solution attains a saturation and form a crystals. Now scrapped surface crystallizers. It contains a chilled vessels. It causes the solution to crystallize on the wall of the surface. By using the blades in rotation against the walls to dislodge the formed crystals. Once collected, the crystals are returned back to the bulk of the solution for growth and ultimate extraction as a slurry for further separation in the centrifuge. This is a scrapped surface crystallizers used among the industry. Now drying. Drying involves the final removal of water from a heat sensitive material, ensuring there is no loss of viability, activity or nutrition value of the product. Drying is undertaken to reduce the cost of transport and to package and handle material more easily from one place to another. Now the drying plays a major step in product polishing step. To avoid the contamination of any other substances and also easily transportable. Now definition of drying. Drying is defined as the removal of a small amount of water from solids at a temperature below its boiling point. This is the definition of drying. Drying curve plays a major role to describe a drying process in the product polishing step. Drying curve usually plots the drying rate versus drying time or moisture content. Three major stages of drying can be observed in the drying curve. They are transient early stage, constant rate period, falling rate period. In case of transient early stage, during which the product is heating up, this is called transient period. Now constant rate period, in which moisture is comparatively easy to remove. At last, falling rate period, in which moisture is bound or held within the solid matrix. These are the three major stages observed in drying curve while drying process. Now critical moisture content. The moisture content at the point when the drying period changes from a constant to a falling rate. That point is called critical moisture content. This is the drying curve. It contains initial period, constant rate period, falling rate period. These are the various stages involved in the drying process. This curve indicates the drying rate curve as a function of moisture content. In this curve, it mentioned as A, B, C, D and E, where AB is the initial adjustment period, BC is the constant rate and CD is the first falling rate period and D is the second falling rate period. This curve indicating the drying process occurs in the product polishing step. Now, equipment used for drying. Dryer is the equipment used for drying process in industry. There are different types of dryers used for drying process. It includes vacuum tray dryer, freeze dryer, rotary drum dryers and spray dryers. Among these, freeze drying is the most common dryer used for drying process in industry. Now vacuum tray dryer. Vacuum tray dryer works by removing moisture through a vacuum created. A vacuum oven is a typical form of equipment used in this process to remove the moisture content from the product. The product to be dried is kept in a tray which is then put in the oven for the drying process. Now the water vapor that is produced from the drying process is sent into the condenser of the vacuum oven and the dried product is then removed from the trays. This is useful for products that are more sensitive and also the product which are heat liable, and also the process used for the purification or drying process. Heating of the product is around 25 to 30 degrees Celsius due to the low pressure inside the vacuum oven. This is the equipment of vacuum tray dryer, and also this is a schematic representation of vacuum tray dryer. Now freeze drying. It is the most common drying process involved in the industrial field. It contains 4 stages: pre-treatment, freezing, primary drying and secondary drying. Pre-treatment. Pre-treatment includes any process that is required to treat the product prior to the primary freezing and drying process. For most of the pre-treatment process, the steps taken are established based on theoretical knowledge or production requirements such as quality or quantity requirements. Now freezing. In an industrial sized freezing facility, a freeze drying machine is used for freezing process. The product is typically cooled to a temperature below its triple point. Thereafter, sublimation occurs in place of melting, which is useful for the steps to follow in the freeze drying process. Now primary drying. In this part, the pressure is lowered in the system to a range of few millibars. Now the enough heat is applied to the system so ice will sublimate. This is done by calculating the latent heat of sublimation for the process, and the amount of heat can be determined. There is typically a condenser in the freeze drying machine for the water vapor to condense and solidify on as a place to remove the water. Now the secondary drying. In the primary drying phase, around 95% of water will be removed. Rest of the water will be removed in this drying step. The remaining unfrozen water molecules will then be removed in this phase. In the secondary drying phase, the system is heated to a temperature where the physical or chemical interaction between the water molecules and the frozen material can be broken, which means physical and chemical properties between the water molecules will be broken in this step. In this stage, the pressure is lowered even further to a factor of a few microbars compared to a primary drying process. While at last the freeze drying step, the final product contains less than 1% to 4% of water content only. This is the schematic graph diagram while a freeze drying step occurs. Rotary drum dryer. Rotary drum dryers are made up of large rotating cylindrical tube with a slight slope using the gravity force for material transfer. Rotary drum dryers can be used for temperature stable bioproducts. The material is in contact with the heating surface for 6 to 15 seconds with a general heat transfer coefficient of 1 to 2 kilowatt. This is the rotary drum dryer used in the industrial field. This is the one type of dryer used for drying the product. Now spray dryers. It is very economical and widely used option is the spray is one of the drying process or dryer used in the drying process. Here the starting material has to be liquid or a paste so that it can be atomized through a nozzle. The small droplets are sprayed into a heated chamber and fall into a spiral stream of hot gas, usually 150 to 250 degrees Celsius. The small droplets can have a relative high surface, and so the drying rate is relatively high and in direct correlation to the droplet size. The material can so be dried completely in seconds, and the cooling effect from evaporation prevents the material from overheating. Spray dryers are used for very heat sensitive materials, but one disadvantage is that it is expensive to purchase but economical to operate. So it can be widely used for product polishing step. This is the schematic diagram of spray dryer used in industry. One of the example of production process of antibiotic. In this step, first we have to remove the solids or cells from a fermentation broth by filtration process. Now filtrate will obtain. It contained a crude antibiotic. Now we have to isolate the product by using solvent extraction step. So we have a extract and raffinate. Extract where the product will occur, and raffinate is the solution where the unwanted material present. So we get the product in the extract. So we have a extract. We going to purify the product by using stripping process. Now we obtained a pure aqueous extract. So it is going to polishing by using crystallization and drying. We obtain a pure product, and at last for packaging we use the lyophilization process to transfer a material from one place to another place. These are the some of the downstream processing steps involved in the production of antibiotic process. Thank you.